Periodic classification of elements. At present, 118 elements are known to us. Out of this, 98 are naturally occurring. Dobrynian's traits. When the three elements in a trait were written in the order of increasing atomic masses, the atomic masses of the middle element was roughly the average of the atomic masses of the other two elements. Why system of classification was not found to be useful, as he could identify only three traits from elements that were known at that time. So the system of classification was not found to be useful. Limitations. First, Newland's law of octaves. In 1866, John Newland arranged the then known elements in the order of increasing atomic masses. He started with the elements having the lowest atomic mass and ended at thorium, which was the 56th element. He found that every eighth element had properties similar to that of first. So limitations of Newland's law of octaves. Properties of lithium and sodium were found to be same. It was found that the law of octaves was applicable only up to calcium, as after calcium every eighth element did not possess properties similar to that of first. It was assumed by Newland that only 56 elements existed in nature and no more elements would be discovered in the future, but later on several new elements were discovered whose properties did not fit into the law of octaves. And in order to fit elements into this table, Newland adjusted two elements in the same slot but also put some unlike element under the same note. Main credit for classifying. So this were all till here were the limitations of the Newland's law of octaves. Now main credit for classifying element goes to Dmitry Ivanovich Mendeleev. He arranged elements on basis of their fundamental property, the atomic mass, and also on the similarity of chemical properties. So Mendeleev arranged elements based on their fundamental property, atomic mass, and also their chemical properties. Now, Mendeleev selected hydrogen and oxygen as they are very reactive and formed compounds with most elements. So, he mainly suggested hydrogen and oxygen. Periodic law states that the properties of element are the periodic function of their atomic masses. So, in a periodic table, the vertical columns that are there, they are known as groups, and the horizontal rows are known as periods. Elements discovered later were scandium, gallium, and germanium. Why noble gases like helium, neon, and argon discovered later? Because they are very inert and present in extremely low concentration in our environment. So they were not able to discover them before. So it was discovered later because of their little quantity in our atmosphere. Strength of Mendeleev period. When these gases were discovered, they could be placed in a new group without disturbing the existing order. So what had happened in the behind the octaves, law of octaves, in that periodic table, they couldn't place a new group, but in this they can place new elements without disturbing the existing order. Now the limitations, this also had limitations. So they were electronic configuration of hydrogen resembles that of alkali metal. Like alkali metals, hydrogen combined with halogens, oxygens, and sulfur to form compounds having similar formula. Just like halogens, hydrogen also exists as diatomic molecule, and it combines with metals and non-metals to form covalent compounds. No fixed position can be given to hydrogen in the periodic table. Isotopes were discovered long after Mendeleev had proposed his periodic classification of elements. Isotopes of an element have similar chemical properties but different atomic masses. Atomic masses do not increase in a regular manner in going from one element to the next. So it was not possible to predict how many elements could be discovered between two elements, especially when we consider the heavier elements. Modern periodic law. Properties of elements are a periodic function of their atomic number. Now, what is atomic number? Atomic number gives us the number of protons in the nucleus of an atom, and this number increases by 1 in going from one element to the next. Elements, when arranged in order of increasing atomic number Z, lead us to the classification known as modern periodic table. Elements containing the same number of valence electrons. Similarly, you will find that the elements present in any one group have the same number of valence electrons. So why does that happen? Because groups in the periodic table signify an identical outer shell electronic configuration. On other hand, the number of shells increases as we go down the group. Valence shell electrons increases by 1 unit as the atomic number increases by 1 unit on moving from left to right in a period. Atoms of different elements with the same number of occupied shells are placed in the same period. Sodium, magnesium, aluminum, silicon, phosphorus, sodium, chlorine and argon belongs to the third period in the modern periodic table, since the electrons in the atoms of these elements are filled in K, L and M shell. Maximum number of electrons that can accommodate in n shell depends on the formula 2n square, when n is the number of the given shell from the nucleus. Now K shell can accommodate 2 elements, L can accommodate 8 and M can accommodate 18 elements. That is in the structure. If this is your nucleus, the round, so this is the first line which will be your K. Then the next one will be your L, and the last one will be your M shell. So these are 3 shells. The position of an element in the periodic table tells us about its chemical reactivity. Valency. The valency of an element is determined by the number of valence electrons present in the outermost shell of its atom. Atomic size. The term atomic size refers to the radius of an atom. The atomic size may be visualized as the distance between the center of the nucleus and the outermost shell of an isolated atom. Now, atomic radius will decrease when you move from left to right along a period. Now, why does that happens? Because an increase in nuclear charge, which tends to pull the electrons closer to the nucleus and reduces the size of an atom. So this can come as a give reason why atomic size, why atomic radius decreases moving from left to right. And atomic size will increase down the group. This is because new shells are being added. As we go down the group, this increases the distance between the outermost electron and the nucleus, so that the atomic size increases in spite of the increase in the nuclear charge. The metals like sodium and magnesium are towards the left hand side of periodic table. Non-metals like sulfur, chlorine are found on the right hand side. In the middle we have silicon, which is classified as a semi-metal or metalloid because it exhibits some properties of both metals and non-metal. A zigzag line separates metals from non-metal. The borderline element boron, silicon, germanium in properties are also called as metalloids or semi-metals. Metals tend to lose electrons while forming bonds, that is, they are electropositive in nature. Metallic character decreases across a period and increases down a group. Give reason. As this happens because as the effective nuclear charge acting on the valence shell electron increases across a period, and the tendency to lose electrons will decrease. Down the group, the effective nuclear charge experienced by the valence electron is decreasing because the outermost electrons are farther away from the nucleus. Therefore, they can be lost easily. So this from here down the group, this can come as another feeling. Down the group, the effective nuclear charge experienced by the electrons decreases. Why? So this will be your answer, because the outermost electrons are farther away from the nucleus. Non-metals are electronegative. We said metals were electropositive. So non-metals are electronegative. They tend to form bonds by gaining electron. Non-metals are found in in the right hand side of the periodic table towards the top. This trend also helps us to predict the nature of oxides formed by the elements, because oxides of metals are basic and non-metals are acidic.